All right, here we're given a natural monopoly. If you need a second, you can pause and read part one as we go through, but I'm just going to go ahead and get started with part A. You can pause this at any time. So assume that a private firm owns the bridge and maximizes profit. Based on the diagram, determine each of the following: output and price. Well, we always determine output from MR equals MC because that's where it's maximizing profit. And then notice that MC is 0, and so where it meets MR is at Q2. So output would be Q2 is the correct answer. Now, price has to be derived from the demand curve because price equals demand. So Q2 doesn't give us the price. We have to draw up, and sure enough, the price is $7. Part B says now assume, so they're kind of cancel part one or part A and think about something else. So now assume that a municipality owns the bridge and sets the price to achieve allocative efficiency. Based on the diagram, determine each of the following. Well, allocative efficiency is simply when marginal benefit equals marginal cost. Now, they were lucky enough to tell us that this is the marginal social benefit, the demand curve. Otherwise, we can say, sometimes you have to derive marginal benefit to the demand curve, sometimes marginal cost from the supply curve, so it just depends on what they give you. This one, it's simple because they give you both, marginal benefit and marginal cost. So what would be the output? It would be where those two curves meet, which would be at Q4. And because the demand curve is the price curve and the marginal benefit curve is the price curve, the price would just simply be $0. If they would have asked the question, they would have had to subsidize it, but they mentioned that the municipality is going to own it, so the government's going to own it. But in this case, at Q4, this bridge is operating at a loss and would have to be subsidized if a private firm still owned it. So part C then goes on to something else. At a price of $1, the municipality's accounting profit positive, negative, or 0, and explain. Now, this might be tricky because if you're thinking like right away, well, at a price of $1, let's go over. Average total cost equals price, so we're making 0 economic profit, and that's the key. But they're asking, what is the accounting profit? And that's where it took a lot of students up, where they just, 0 and that's it. However, what we can say about the accounting profit is that the accounting profit is positive because we have 0 economic profit. And that would be a good enough explanation. Why is accounting profit positive? Because economic profit is 0. So part D then, suppose that the municipality sets a break-even price that generates revenue to just cover all economic costs. They already defined that for us in part C without actually telling us that that was the break-even price. A break-even price is when, total revenue equals total cost. Or on the graph's sake, what we're looking at is, P is equal to ATC, which is that blue point on the graph. So based on the diagram, determine the break-even output. That would simply be Q3. At the output, you determine in part B1 is demand relatively elastic, relatively inelastic, unit, perfectly or perfectly inelastic. Well, we can cross these two out right away because that's not going to work. The unitary elastic point is when MR equals 0, so we don't have to worry about that because at Q3, MR is not 0. So we can cross that one out. Then with the demand curve, MR equals 0 kind of defines unit elasticity at a price of $7. Anything to the left is elastic. Anything to the right of unitary elastic is inelastic. So sure enough, it just asks us to determine. So all we would have to say is, well, it's relatively inelastic. There are two other questions here, part E and part F. If a company begins to provide access to the island via commercial watercraft, what will happen to each of the following in the diagram? The demand curve for bridge crossings. Well, we have to kind of assume that the commercial watercraft is a substitute for crossing the bridge. So demand would fall. And what it's asking too is the demand curve, so you may just want to make sure it shifts left. There's decrease in demand, shift left. But it does ask about the curve, not just about demand itself. We'd want to say decrease in demand, shift left, just to cover our bases there. So what would happen to the profit maximizing output? We'll have to go up to the graph just to kind of show. And if I shift demand to the left, there it is. Then what we would notice is profit maximizing output. So that my MR curve would shift as well, where MR equals MC. So what would eventually happen is quantity would fall. My profit maximizing output would decrease. And then the last part, part F, the long question. Suppose the long run average total cost is strictly downward sloping, like it is on the graph. We know that this is a natural monopoly. Would it be efficient to build a second bridge in this flight? The answer to this would be no. And then you'd have to come to the conclusion of, well, why is this natural monopoly which the most? Yep. As well as adding a second bridge, it would increase the total cost. So there's a full worked out HVAC problem on natural monopoly.